Continue with trigonometry, exercise 8D, question number 13.3. We have cosec theta by cosec theta minus 1 plus cosec theta by cosec theta plus 1. We have to prove that it is equal to 2 sec square theta. If we look at the denominator, we have same quantity 1 plus 1 minus. So what to do? Let us find the LCM. Since both have different sign, we have to take both as LCM. Then if we look at numerator, we have same quantity cosec theta. So let's take common, okay, this one. Then if we divide this one with this, we are left with plus. So this one we multiply this one we will put this side, let's put inside bracket. Then we have plus. If we divide the denominator with LCM, plus get cancel, we are left with minus. Then here inside bracket we have plus 1 minus 1, we can cancel. Cosec both plus, we can plus. So 1 plus 1, it will be 2. Then here we can apply a minus b, a plus b, it will be a square minus 1 square. So 1 into 1, 1. Then here cosec into cosec, we have cosec square by, and then 2, let it remain. 2 it remain. Next we want sec square theta. From the denominator, cosec square theta minus 1, we can apply identity, which is equal to cot square theta. In the right hand side, we want only sec square theta, so let's use the relation. Cosec theta, from the relation we know it is 1 by sine. Since here we have square, let's put square. Cot square theta is below, so the relation of cot square theta we know cos square theta by sine square theta. So sine square theta, we can cancel, 2 remain 2. So 1 by cos square theta, it is equal to sec square theta, which is equal to right hand side. Let us take with 14, 1. We have sec theta plus tan theta minus 1, sec theta minus tan theta plus 1. We have to show that it is equal to 2 tan theta. We have two separate brackets, so what to do? Let's multiply them. Sec theta into sec theta, we have sec square theta. Sec theta into minus tan theta, both are different. We have to write them both. Sec theta into 1 sec theta. Then next we'll multiply with the second term, that is tan theta. Tan theta, sec theta, both different, we write them both. Here both plus, so remain plus. Tan theta into tan theta, plus to minus, minus tan into tan square. Then we have plus tan theta into 1, it become tan theta. Then we multiply it minus 1. Minus 1 into sec theta become minus sec theta. Minus to minus plus tan theta into tan theta, 1 into tan theta. Then minus to plus minus 1 into 1, 1. So let us see here sec square theta, we cannot do anything, write it as it is. Here you have minus sec tan. Here also you have sec tan plus. So this one and this one get cancelled. Then we have sec theta plus sine. Sec theta minus sine, so that we can cancel. Then we have minus tan square theta alone, you write it there. Then tan theta, both plus, we cannot cancel, so we plus them. 1 plus 1 will be 2 tan theta, we are left with minus 1. Then from here, if we check the identity, sec square theta minus tan square theta, it is equal to 1 using identity. So 1 minus 1 becomes 0, equal to 2 tan theta, which is equal to right hand side. We will move to 14 number 2. Similarly the same. Then we have 2 bracket. We have to get that it is equal to 2. So 1 plus cot theta plus minus cosec. Since we have different quantity, then difficult to multiply them, difficult to arrive at the result. So what to do? We'll change everything to sine and cos. So 1 remain 1. Cot we know it is cos by sine theta. Cosec we know 1 by sine. Then 1 plus tan theta we know it is sine by cos. Sec theta we know 1 by cos. Okay, so after we change like that, since we have fraction with plus minus, let's find LCM. Here we have separate bracket, so we'll find LCM in separate bracket. If you look here, sine theta 1, so the LCM will be sine theta. 1 divide sine theta, we get sine theta, so sine theta into 1 sine theta. Denominator and LCM same, numerator remains same. Here also denominator and denominator same, numerator remains same. Okay, let us see the other bracket. Here also we have, in the denominator we have 1 cos theta cos theta. So we can take cos theta as LCM. 1 divide cos theta, it will be cos theta into 1 cos theta. Denominator LCM same, so numerator remains same. Now sine into cos, denominator we multiply them. Let's write together. If we observe here, we have this quantity and this quantity same. Here we have minus 1 plus 1. So if I group sine theta plus cos theta as A, then minus B, A plus B. So we can apply the formula A minus B, A plus B, but we group sine theta plus cos theta as A, so it will be equal to A square minus B square. So here we can apply the formula A plus B whole square. So A square plus B square plus 2AB, then 1 into 1, 1. So minus 1, and here sine square plus cos square from identity is equal to 1. So 1 and minus 1 become 0. We are left with 2 sine theta cos theta. So here sine theta cos theta, we are left with 2, which is equal to right hand side. We will move on to number 15. We have here sec to the power 6 theta. We want to produce this one. We don't have formula 6, but we have formula 2 and 3. So instead of 6, let us change it 2 whole to the power 3. Then sec square theta, we have identity, we can make it 1 plus tan square theta, then whole to the power 3. Since we have whole to the power 3, we can apply the formula A plus B whole cube. Your A is 1, your B is tan square theta. So it become A cube plus B cube plus 3AB inside bracket A plus B. Okay, then 1 into 1 into 1, 1, 2 into 3, 6. Then this one no need to change because we want tan 6. Then plus 3 tan. Here we have 1 plus tan, but here we have sec theta. So 3 into tan, 1 plus tan square theta. From identity, we know it is equal to sec square theta. So if we compare what we get, and the right hand side is the same. So it is proof. Then we'll proceed to the next one, that is 15.2. So more or less it will be same like 15.1, okay? Here we have cosec for 6, we want cot and cosec. So we don't have formula 6, so let us change it as 2 and 3. Then 2 we have identity, we can replace cot theta plus 1 whole cube. Use this one as A, this one as B. We can apply formula A plus B whole cube will become A cube plus B cube plus 3AB inside bracket A plus B. Then 2 into 3, 6. We get that. Then next here we want, here we have plus 1. We get that. Then 3 cot square theta. This one we don't want. We want cosec. So from identity we know cot square theta plus 1 equal cosec theta, which is equal to right hand side. Okay. Then next we have here tan A plus sine A, tan A minus sine A. We want sec A plus 1, sec A minus 1. So let's convert everything to sine and cos. Tan A, we know the relation sine A by cos A, both numerator and denominator. Then since we have fraction, let's find LCM, both numerator and denominator. Cos A and 1, okay, sine A, we can take common. So here if I take sine A inside bracket, we are left with 1 by cos A plus sine, don't take common. Here remain 1. Then denominator also same. Sin A we can take common. Here we are left with 1 cos A minus 1 because sin A we will take this side. From the relation, sin A we can cancel. From the relation, 1 by cos, we know it's equal to sec. Here also 1 by cos equal to sec, which is equal to right hand side. Next we go to number 17. Here we have sine cos, we have to produce only sine. Oh, we know from identity because we don't want cos, so let us use identity. Sine square A, let it be. From identity we know cos equal to 1 minus. Since here we have B, there also we write B. Okay, here also we don't want cos, so we can convert 1 minus sine square. In here we have A, there also A. So now we multiply sine square A into 1 sine square A. Sine square, but here A and B, so we write them both. This side also we multiply, minus to plus minus, 1 into sine square B, minus to minus plus. Here we have sine square, but 1A, 1B, so we write them both. Then let's compare. Here we have sine square A, sine square B with plus. Here we have sine square A, sine square B with minus, so we cancel. We are left with sine square A, sine square B, which is equal to right hand side. Then here also same way you can do. We have tan sec, but we want only tan and tan. So let us remove sec by using identity. Tan square A, sec square B, from identity we know it is 1 plus tan square B. Here also sec square A we don't want, so we convert identity 1 plus tan square A. Then tan square B, let it be because we want in the right hand side. Then here also we multiply. Then though we have tan square, but 1A, 1B, so we write them both. Then here be careful with minus sign. Minus into plus, minus to plus, minus. Okay, so this one minus, this one plus, we can cancel. So we are left with tan square A minus tan square B, which is equal to right hand side.